Let's talk about standard deviation and why it is a better measure of dispersion. Now, to understand this better, let's take the same situation that we have player A and player B. And the situation is we have a match to be won. Let's say it's a final match, maybe World Cup, and we need 50 runs to be scored. So which player is a better player? Now, how will I understand that? From the previous history of the data collected. This is a situation. We'll see how we can understand and make a right decision. Come back to this. Let's say player A scores like this. Now I'm just putting the scores like that: 59, 45, 65, 73, 61, 65. Clear enough. I add all the scores. I get 325. Look at that. I'm getting sigma x, which is 325 divided by n, the number of scores. What I'm doing here is finding the mean. That is simple. We know this from the last year, right? That is mean. That is 65. We got it. It means what? On average, player A can score 65 runs. Now, he may score 59 also. He may score 67 also, 73 also. But the average he can score is 65. That's what we understand by mean. Now, what is standard deviation? See, what we do is this. We'll take deviation of the score of the mean, or the score from the mean. Let's say that is 59. I write 59 minus 65 is minus 6. So that's how the first score is deviating from the mean, right? The second score is like 65 minus 65, that is 0. So there's 0 deviation. The third score is deviating by the mean by 73 minus 65 is A. So that's how we calculate the deviation basically. It means the score minus the mean. What you get is this. Very simple. We understand this. What we do is we square this, right? We square the d. It means minus 6 the whole square. That is 36, 0, 64. As if we don't have any negative numbers now. And we add this. Okay, sigma d square. It means I'm adding the squares of the deviation. That's what we understand. So what I get is sigma d squared. Now, standard deviation is very simple. That the square root of the sigma d squared by n, or the average of the deviation square. All right, I'm just taking the square root of the average of deviation square. That is standard deviation. And look at that. I get 120 over 5, which is like 24 root of 24, which is like 4.8989. Okay, now let's go back to the definition. Look at this. What it says: standard deviation is nothing but the square root. Look at that, square root of the average. Average is nothing but sigma d squared by n, right? So average of what? The squared deviations from the arithmetic mean. So that is nothing but d. The squared deviation from the arithmetic mean is called standard deviation. That's a very simple definition. Now, what do we understand by the data? Look at this. The standard deviation like 4.8. Let's say it's 5, almost 5. It means player A can score, let's say, he can score out of the mean 65, he can score 65 plus, let's say, 5. I'm just assuming this to be 5. So he may score 70, or he may score 65 minus 5, like 60. So it means he may deviate from the mean, maybe positive, like 65 plus 5, 70. Or he may deviate in the negative side, that is 65 minus 5, 60. It means he's sure of at least scoring how much? 60. So if I have to send him to the match, basically where I need 50 runs, player A is actually good because he may score lowest 60 or max 70 because his deviation or standard deviation like 5 from the mean. That's what we analyze from the data. Let's come back to player B. Okay, player B, he could score like 83, 120, 40, 22 and 60. That's what his scores were. We added them all, we get 325 again, and I calculate the mean, which is sigma x, that is 325 by n, which is again 65. That is the average he can score. But the standard deviation, how much did he deviate from the mean? That is important. Look at that. He deviated like the first score, 83 minus 65 is 18. He deviated like 18 runs in this first score. Now 120 minus 65, like 55 is a huge deviation, right? So like that, these were the deviation. We squared the deviation and we added them. We got 6024. Now look at that. Standard deviation is 6024 by 5, which goes like this, and I get like 34.71. Right now, let's say it's around 35. So I'm just writing this as 35. Okay, rounding it off to 35. It means what do we understand by about the player B is this: he may score 65 plus 35 because his deviation is like 35 from the mean. So he may score like 100 runs, possible, or he may score 65 minus 35. Maybe he can score 30. Now, what if he scores 30? I will lose the match. Not the right player to send at that time. Possibly he may score 100, maybe, may not be, but his standard deviation says that he may deviate from 65 positive 35 or negative 35. A good thing would be to send this player in the starting of the match where he may score like 100, right? But at the moment where we need 50 runs and we need one player who is sure of hitting 50 runs, that is player A. Why? We understand by the standard deviation. Okay, that's the use of standard deviation, and that's why it is better than only the central tendency like mean. All right, so let's go ahead now. In the coming videos, let's talk about the ways of measuring standard deviation. There are 4 methods we need to learn. Let's learn them one by one.